Hi, we're going to start talking about Chapter 3. Um, Chapter 3 in a traditional book is about two-dimensional motion, but we are going to treat our Chapter 3, or what you might call the first half of Chapter 3, we're going to sort of split this up, dealing with some trigonometric ideas. This is moved from the end of Chapter 1. This gave you some time to move ahead in your trigonometry courses so that you could get to here. Um, as I say frequently in class, you were going to learn stuff first period that you were going to use second period. You were going to learn stuff in trig that you were going to use in physics the next day. And it's important that you recognize and remember the things you're learning in trig. The answer to the question always of where am I going to use this is physics. Whenever you're in a math course and you think, where am I ever going to use this? The answer is clearly physics. So here we go. Trigonometry comes to us from the ancient Greeks. Hipparchus of Nicaea came up with is considered the founder of trigonometry, and he is going to give us the idea of tres goniometrae, which is three-angled measure, or trigonometry. When we are talking about trigonometry, for right now, the main focus is going to be on a idea that we have learned in our trig courses called SOHCAHTOA. And this idea gives us the fact that the sine is equal to the sine of an angle, so theta, is equal to the opposite over the hypotenuse. The cosine of an angle is equal to the adjacent over the hypotenuse, and the tangent of theta is equal to the opposite over the adjacent. These are for 90-degree right triangles only. That's very important. It has to be a 90-degree right triangle. In physics, we are only going to deal with right triangles. Have gone through the course a number of times now, and I know that everything we are dealing with is going to be a right triangle until we get to Chapter 25 in AP Physics 2, and we deal with optics, and at that point, we take that triangle and we turn it into a right triangle because we can drop down in altitude. So everything ultimately is going to be a right triangle in physics. So if you see the law of sines or the law of cosines in your trig course, do not use them in here. Do not use them in physics. Do not use them in physics. I say that because sometime between the start of this chapter and the end of this chapter, Mr. Carter or Mrs. Martin are going to teach you about the law of cosines and the law of sines. And I am telling you, this happens every year. Somebody shows up on my test and starts using the law of cosines or the law of sines. Do not do it. With that said, we are going to focus on the idea that SOHCAHTOA is going to help us solve for the triangles, solve for the sides or the angles of the triangles. One of the things that you need to know is where this idea of SOHCAHTOA came from. It is important. It is very important that you always ask the question. And the question that you need to ask is, where did these terms come from? So when we're talking about the term sine, we need to think about our unit circle. If we draw a circle and we are going to have a line that comes out on that circle, if this is the x-axis, we are going to have a line that touches at that point. The line that touches that point is called the tangent. You learned in your trigonometry courses we talked about this in Chapter 2. Line that intersects or cuts the circle is a secant. Secant means to cut in its etymological basis. It's Latin and Greek root. Tangent would be to touch. And so what we can see here in this picture on the left is that we have the line out to the tangent point. And so it's called the tangent line. The secant is going to, again, is going to be to cut. And then sine is the chord. So that comes to us from the meaning of a chord. These definitions have totally been lost over time. So sine, cosine, and tangent ultimately are just terms that are placeholders now, as I'm about to show you. And so the chord, you could see this would like connect this. It's the chord, and then the complementary chord, or is called the complementary sine. Chord is sine, so it would be complementary sine or cosine. And so we get our tangent, our sine, and our cosine. We're going to come back to this idea of tangent, sine, and cosine later on in physics. We're actually going to use those. And so what then is the tangent, sine, and cosine? Well, the answer to that question comes to us from the idea that if we had a triangle, and this was a 3, 4, 5 triangle, then we had another triangle, and this was a 6, and I say this triangle similar to the first triangle, it would be a 6, 8, 10 triangle. You learn this in geometry. Similar triangles, and so on and so forth. I could have a bigger triangle that's 12, 16, 20, so on and so forth. What we find, though, what early mathematicians studying trigonometry found is that the angles here were also the same. And so these are 90-degree triangles. And so if this is a 90-degree angle and this is theta, and this is a 90-degree angle and this is theta, then I actually don't need to know two sides to figure out the third side. I only need one side and an angle. And so I don't need side angle side congruency, side angle side congruency. I can use angle side angle congruency. That's all from geometry. And so what that means to us is that if I have another triangle and I say this side is 9 and this is theta, you know immediately that this, and this is 90, that this triangle is similar to the other two. And so without doing anything else, we can now put up here the number 12, because this triangle here was double, 3 times 6, and then this triangle is 3 times 3, or 9, so this would be 4 times 3, or 12. And so we get our similar triangles. That's trigonometry. Trigonometry then says that if we think about this and we make a table of data, so if I have a triangle, and I'm just going to do this one example of this. Let's start here. We have a 1 by 1 triangle, and then we have a 2 by 1 triangle, and then we have a 3 by 1 triangle, and then we have a 4 by 1 triangle. We keep measuring the angles, the different angles down here. What we find is that the 4 by 1 triangle has a bigger angle than the 3 by 1, which has a bigger angle than the 2 by 1, which has a bigger angle than the 1 by 1. And that angle, if I measure it, is always going to be the same. Whenever I have a 1 by 1 triangle, the angle over here is going to be the same. That 1 by 1 triangle means opposite and adjacent, right? Opposite and adjacent. We immediately think tangent. So this becomes the angle to represent that tangent relationship. And so the tangent relationship is 1 over 1, opposite over adjacent. In the first triangle, it's 2 over 1 in the second triangle, it's 3 over 1 in the third triangle, it's 4 over 1 in the fourth triangle. And so now we can write down what those angles are in a table, and when we have that ratio pattern of 1, 2, 3, 4 in a table, whenever we see it, we can immediately know to use that ratio to solve for the missing sides. So what happened is, just like when you did the circle lab to find pi, mathematicians did experiments to figure out what the magic ratios were. And so the ratio of 1 they measured was a 45-degree angle, and that is located down here on the lower part of your screen right here. And so there's your 1 for the tangent function. That's the tangent column, and so that means that 45-degree angle. When we had the 2 they did the measurements and they found that that was about a 64-degree angle. When we had the 3, they did the measurements and they found that the value for 3 was about a 72-degree angle. The 4, that's about a 76-degree angle. And so by doing this experiment with a variety of different triangles, we're able to come up with patterns, and you would see this table. Up until the advent of the scientific calculator, people had to go look at a table like this. When we got a scientific calculator, we forgot about this table because they programmed it into the calculator. But all you're doing is a primitive Google internet search with your calculator. So today, if you want to look something up, you type it in the Google search box. If you wanted to type up the question of what is the ratio of a 1-by-1 triangle, you would say, oh, with the hypotenuse of one, with a 2 legs of one, you'd type that in, opposite over adjacent, into your calculator, and boom, your calculator searches for it and finds the number 1 and then puts it on your screen. And then you do your math from there. That's all you're doing. So when you do the sine or cosine or tangent in your calculator, you are just looking up a number from this table. Tomorrow, we are going to talk about the idea that we can use this table and your calculators to solve for missing sides and missing angles in triangles. Have a great day.